The purpose of this lab is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring and applying Newton's second law and the energy principle to predict the motion. This lab also applies Newton's second law by using location data from Tracker to generate predicted forces on the system, therefore creating its own position data. This lab uses this position data to predict the energy of the system as well, creating a realistic model that uses the energy principle to further understand the characteristics of this motion as well as how to tell if a model is following the energy principle. Using Tracker, I was able to collect information on the motion of the mass on the spring. Starting from static equilibrium, the mass then oscillated in multiple dimensions, therefore involving both x and y coordinates, unlike the observed motion in the lecture. Using Tracker, I was able to collect the mass of the object attached to the spring as well as its location as it oscillated in accordance to the scale that I set. I collected the x and y coordinates of the object just after it was released from rest. I also used a graph of the x position over time and the y position over time to further understand how the mass is oscillating. While I collected all the information I needed to predict the motion of the object using Newton's second law from the observations, I also needed to use all this information observed to predict the energy of the object as it oscillates using the energy principle. First, I entered all the initial values needed to predict the motion of the mass using Newton's second law, as well as initializing the spring length needed to calculate the spring force. All calculations for Newton's second law used the mass as the system. I also established the initial energy of the system of the mass, spring, and earth, which is the system I chose for implementing the energy principle so that the work on the system would be zero. Therefore, the change in energy would always be zero. Examining the established system, I decided that there were three energies that acted on the system: the kinetic energy from the object in motion, and potential energy from the influence of the spring as well as the earth, for the earth is included in the system. Therefore, I also initialized the kinetic energy, potential energy due to gravity, and potential energy due to the spring using their respective equations. This model also required iteratively recalculating all the values derived from the energy principle and Newton's second law because the object is in motion. Furthermore, this iterative recalculation is needed because I needed to calculate the net force on the object for each iteration. Looking at the system, it is obvious there are two forces acting on the system that I am interested in: the force of gravity and the force of the spring. While the force of gravity stays constant as the mass stays constant, the spring force changes regarding the length of the spring at any moment, requiring constant recalculation. This constant recalculation is needed to recalculate the new velocity, then the new position. This change in spring length also affects the total energy, for the change in velocity, height of the mass, and the change in spring force affect all three energies on the systems, which means they must be recalculated every iteration after the object's new motion is predicted. The change in energy should remain zero, but the changing levels in energy of the other energy components could be affected, so it is important to recalculate them as well. For running my model, I was able to uncover more information about the motion of the mass as well as the energy transfer happening. In terms of position of the mass, my model predicted that the amplitude of the oscillation was slightly larger than the observed motion of the mass, which is probably the result of a measurement error on my part. However, the most interesting graph that my model created was the graph of all levels of each energy throughout the mass's motion. The change in energy, which takes into account kinetic energy, gravitational potential energy, and spring potential energy, was always zero because the work done on the system of the earth, mass, and spring is zero because there's no work acting on the system, which also satisfies the energy principle as a change in energy is equal to the work done. Also, one can observe that the kinetic motion oscillates about twice as fast as the potential energies. The level of energy also changes throughout the motion of the object, particularly for kinetic energy, on account of the nature of the trajectory. It moves in an ellipsoid, meaning sometimes it takes longer to complete a rotation than other times, causing increases and decreases. When calculating the period of oscillation for the mass using the x position and y positions, I got two different answers for the time. The reason that there are two different answers depends on the forces acting on the object in each direction. In the x direction, the only force acting on the object is spring force, which is acting as a restoring force to the motion, keeping it constant. However, while the spring force is still the restoring force, the force of gravity is counteracting it, causing it to decrease in amplitude, as one can see from the graph.